All right, class, let's cover section 2.5, applications of linear functions. We already did a few applications in the last section, and really all the sections about this, just more of it. So maybe a little bit more challenging problems. So here it is, this first question. I'm actually going to take you super step by step with every question there is, so every part of this problem. So let's get started. In 2003, a town's population was 1,431. By 2007, the population had grown to 2,135. Assume the population is changing linearly. So that is a very important word, because that here tells us that we're going to have to come up with a linear equation in two variables. So in other words, the population of the town changes linearly with respect to the year we're in. Okay. So how much did the population grow between the year 2003 and 2007? So we want to know the growth in population, which was 2,035 at the end, minus 1,431. So that's a difference of 704 people. How long did it take the population? How long? So that's a time to grow this much. So that's between the years 2007 and 2003, and that's 4 years difference. Okay. So what we really found here are just the two key points to find the average population growth per year. So remember, we talked about it in chapter 1. The average population growth is simply the slope of this line, and that's just going to be the population grew by 704 people over 4 years, and that's an average of 176 people per year. Okay, so what we found here is the slope of this relationship, okay, which is the same thing as the average change, rate of change. And it's a rate, yes, so people per year. So a slope is always a rate of change, and change in y's over change in x's. What was the population in the year 2000? Okay, well, we already know that if in 2003 the population was 1,431, and we also know that every year the population's been adding 176 people. That simply means that in 2000, which is 3 years back, we have to count backwards from 1,431. So we count backwards by 176 down from 2003 to 2000. There will be 3 times, right? 3 years. So that's 1,431 minus 3 times 176. So the population back in 2000 was 903 people. Okay. Now it says find the equation for the population P of the town T years after 2000. So remember, it says that we are dealing with a linear relationship, so therefore we need to come up with a linear equation. Yes. And so to come up with a linear equation, all we need is an M and a B. Well, since it says we want to start counting in 2000, that means the B value, the initial value, which that's what B is what happens at time 0. Time 0 is in 2000, is 903. So we did find the slope up above, and that's 176 people per year, starting with an initial value of 903 by the year 2000. And then the couple more things are that our x value should now be called t for time. That's the kind of points that we now have. T is our x, p is our population. So I'm just going to change this equation into a linear function that again is showing us that the population is a function of time. So in other words, the population changes with respect to time. Okay. All right, so here it is. Using your equation, predict the population of the town in 2014. All right. Now, in 2014, that's how many years since 2000? Oops. That's how many years since 2000? Okay, because remember, time is, for this equation, t is years since 2000. So by 2014, there'll be 14 years since 2000. So in other words, we have to plug in 14 for time. All right, and then we can use this equation to figure out the population really at any point in time, assuming that it keeps changing at the same linear rate every year. And that's the story. So we could, again, using this equation that we created, we could figure out the population anytime. So that's the goal, is to come up with this relationship, with this equation that connects these two quantities so we can predict the future. Okay. And here's one more. It says, in 2003, the owl population in a park was measured to be 340. By 2007, the population was measured again to be 284. The population changes linearly. Find a formula. So again, we need to come up with a y equals mx plus b, since we need to come up with a linear equation for the owl population. And let t be the and let the input, the input by us is the x value, yes. And then we're going to call the x value maybe again, you can leave it as an x. The input is always x, but let's just call it t for time, since that's what it represents. Be years since 2003. So that means in 2003, our time is 0, yes? So we can create ordered pairs on time, population, and so therefore at time 0, the population was, so in 2003, the owl population was 340. So that simply means at year 0, in other words, in year 2003, the population is 340. A few years later, it says by 2007. Now in 2007, there would be how many years since 2003? That'd be 4 years, right? So we have the 0.4, and then the population is 284. So you got yourself 2 points right here. And then with 2 points, of course, we can come up with a linear equation. Now, of course, with 2 points, we always want to find the slope first. That's why we are given 2 different points. So 284 minus 340, and this is going to be 4 minus 0. So I'll put this in my calculator. And that would be a negative 14. So that simply means that the owl population goes down by 14 every year, right? So I have all the information given. The slope is negative 14. The y-axis intercept is right here. The y-axis intercept, again, is the point where the value where the x is 0, right? So therefore, b is 340 is our initial value at time 0, which we considered the year 2003. And then the other things that we wanted to do is we wanted to call our x by time and our y by p. So I'm going to go back and change this. And here it is. You can write p or p of t to show it's a function of time. That's fine. One or the other is fine. So now use your model to predict the owl population in 2012. Well, in 2012, t is going to be how much? So again, since t is here since 2003, that's simply going to be 9 years since. Okay. So in this equation, plug in 9 for time and see what happens. If you start with 340 owls in year 2003 and you subtract 14 owls per year until 2012, you're going to get down to 204 owls. 214, I meant, owls. All right. And here's yet another question that's very similar. It says, suppose the world's oil reserves in 2014 are 1,820 billion barrels. If, on average, the total reserves are decreasing by 25 billion barrels of oil each year, give a linear equation for the remaining oil reserves R in terms of the time t, where t is, again, let's count it since 2014. So in other words, in 2014 is our initial value. So right here we have all the information. If we're counting since 2014, that means the amount we had in 2014 is our b value. Okay. So this must be our b. The slope is actually given right here. So many barrels of oil each year, or in other words, per year. So that's a rate of change. And the fact that the reserves are decreasing, that simply means that the slope is a negative value. So we're going down by 25 billion barrels per year. That's a rate of change, so therefore that's our slope. And one more thing, it's call the y by r, call the x by t, and here is your nice linear function. Okay. So it says 7 years from 2014. So 7 years from 2014. That means t is 7. What will be the oil reserves 7 years later? Okay. All right, so here it is, starting with 1820 in the year 2014. You have to subtract 25 billion barrels of oil each year, so you're gonna end up with 1,645 billion barrels. We don't have to write the billions, it's just carrying out too many zeros. But what you need to do is keep those kind of units in your answer. So it's not just 1,645 barrels, it's 1,645 billion barrels. And if the rate at which the reserves are decreasing is constant, so in other words, we keep losing 25 billion barrels each year, when will the world's oil reserves be depleted? So the reserves are depleted means that we have none left. So in this equation above that we came up with from the story, we simply have to solve. In other words, we simply have to substitute R with 0, right? And solve for the time. So that's something we very much practiced at the beginning of this section. So I'm going to minus 1,820 over, and then divide by this negative 25. So it's a simple linear equation now to be solved. So T is 72.8. That simply means the number of years since 2014 is 72.8. Really, we don't need the 0.8. That simply means that it's happening sometimes in the year 2086. Towards the end of the year, all we know, right? Fine, 0.8 means maybe by October kind of thing, maybe by August. But yes, that's what it is. All right. And here are just a few more. It says a phone company has a monthly cellular plan where a customer pays a flat monthly fee and then a certain amount of money per minute used on the phone. If a customer uses 410 minutes, the cost is $71.50. The consumer uses 720 minutes, the cost is $118. Find a linear equation for the monthly cost of a cell plan as a function of X, the number of monthly minutes used. So we are coming up with points. If you want to leave it as X and Y, you can rename maybe then Y as the monthly cost. So the cost, you can call it Y, or you can call it C if you want, but that's your dependent variable. So in other words, that's your Y. So the monthly cost depends on the number of minutes used, right? So that's your dependent variable, your Y. X is your independent variable. That's the one that changes. And depending on this X, on the number of minutes used, you're going to get a monthly cost. So here it is. It says we're using 410 minutes, then the cost is $71.50. And if we use 720 minutes, the cost is $118. So the story simply got translated down to the fact that we are given 2 points and we need to come up with a linear equation. So first things first, of course, we're going to find the slope. So subtract the y's and then subtract the x's at the bottom. So here I have it, a 46.5 divided by 310, which is going to give me 0.15. Great. Now, I'm going to write it to the side. So with this slope, again, it just goes back to the section where we said, here are 2 points, find the equation of a line. Okay, here are the 2 points. We first find the slope, and then we use either one of these points to plug in for y and for x. To find our b. Okay, so here's a y, here's an x, here is the m we found, and then we come up with b. So same thing, multiply the 0.15 to 410, subtract the 61.5 over, so you're going to get that b is 10. So here it is. My equation that describes this story is that y equals to 0.15x plus 10. So in the last stories, we were given maybe the rate of change and the initial value, or the initial value and a certain other point. Now we were given 2 random points to come up with a linear equation. It says interpret the slope and the y-intercept. So the slope is your rate of change in dollars per minute. So in other words, that's the money per minute used on the phone. So it's the charge per minute. So this company is charging basically 15 cents per minute. The B is 10, and that's the charge when 0 minutes have been used. So this is your flat monthly fee. So in other words, B is the value that you get when X is plugged in to be 0. So that's the monthly fee, is $10 before you even used any minutes, right, or talked for any minutes. And now the last one is, once we have this equation, says find the monthly cost if 687 minutes have been used. Okay, so put this in your calculator at a rate of 0.15 dollars per minute times 687 minutes plus the flat fee of $10 no matter what is going to make it a bill of $113.05. So that's, again, the slope is the rate of change. The B value is the initial amount that you get to spend, that you have at time 0 when X is 0. And here just a couple more questions. They're a little bit different, but yet the same. So here it is. It says you're comparing 2 cell phone companies. Company 1 charges $20 a month, so that's your flat fee, for unlimited talk and text, and then $10 per gigabytes for data. Company B just charges $65 for unlimited talk, text, and data. So here you pay $65 no matter how much data you use. In Company A, you pay $20 a month, so that's your flat monthly fee, but then it charges you $10 gigabytes for data. So under what circumstances will Company A save you money? So let's say if X is the number of gigabytes used, then this is the cost in company A. Then for company A is charging you $20 and then $10 for each gigabyte, right? Per gigabyte, so multiplied to the number of gigabytes. Company B is just simply charging you, so this is the cost, right? The cost for company B is just $65 monthly fee, so we don't charge you for anything, okay? So what's going to happen is we're going to try and figure out, fine, when will these two amounts be the same? So basically, I want to find out how many gigabytes will I have to use in order for company A to save us money. So they're going to be the same cost if you're going to use 4.5 gigabytes. So if we use for less than 4.5 gigabytes, then plan A is better. Because then you won't pay as much, yes? But if you think you're going to use more than 4.5 gigabytes, then you should go with a flat $65 a month for unlimited data, right? And here's another one where we're comparing. When hired at a new job selling electronics, you're given two pay options. Option A is a base salary of $20,000 a year with a commission of 12% on your sales. So X is the amount of sales you make for this company. And they're offering you 12% of whatever you're selling, plus a $20,000 a year. Option B offers you a salary of $26,000 a year, but they only give you a 3% commission on the sales. So again, how much electronics you would need to sell for option A to produce the larger income. So in other words, even though you get less base salary, you need to, if you sell more, you're gonna get a higher amount in sales, right? So in sales cut, let's just say. So let's see again, when will these two functions equal to each other? Because here it is, we immediately set them up. You have your base value, your B value, and then you have your rate of change, right? Then salary per sales. So when are these two functions equal to each other? All right, so we'll get the constants to one side. So I'm going to minus the 20,000 over. So again, this is why we so nicely practiced at the beginning of this chapter, because, well, this kind of problems do keep coming up. Then I'm going to minus the 0.03 over, get the variables to one side. So 0.12 minus 0.03 is 0.9, and now all I have to do is take the 6,000 and divide it by 0.09, and I'm going to get the X is 66,666 and 67 cents. So if you're going to make more than to produce for option A, you need more sales, right? Because your base salary is less. So you could have also done this as an inequality. So you could have solved an inequality here rather than, because you wanted option A to be more than option B. So as you see, that simply means the amount of sales you need to make to basically make up for this $6,000 difference is $66,666.67. So that's how much you should make in sales if you want plan A to be better.